Hey everyone, Mr. Voikin here, and today we're on lesson 1.8, Geometry, pages 23 to 30, and we're going to be looking at all the geometric shapes that surround us every day. So what are geometric shapes? Well, they're closed figures, which is just another fancy way of saying shapes, and they're usually made up of straight and curved lines, and we have basically two different types of geometric shapes. The first one we're going to look at are two-dimensional geometric shapes, and these would be squares, triangles, and circles. And later we'll look at three-dimensional shapes, which would be cubes, triangular prisms, and spheres. So we'll start off, like I said, with two-dimensional shapes and specifically looking at angles. So how do we classify angles? Okay, well, you can see here I've got a bunch of terms to the left and a bunch of drawings to the right. So what do we know about an acute angle? Well, it's going to be less than 90 degrees. So that is this one right here. Okay, now when we're looking at angles, we want to know that the angle is going to start off on what we call the initial arm. And the initial arm is going to be this one right here. That is the initial arm. And it ends at what we call the terminal arm. And this is the terminal arm right there. And this sort of arc that's sort of right there is the arc we put in that's going to determine the angle that we're looking at. Okay, the next one says right angle, and what do we know about a right angle? Well, it is equal to 90 degrees, and that is going to be this one right here. And notice that the symbol is not an arc that's showing the angle, it's actually this little square right there. So it's showing that it is square, which is another word for 90 degrees. Okay, the third one is an obtuse angle, and an obtuse angle is an angle that is greater than 90 degrees, and that would be this one right here. I'll bring that over, place it right there. And what about a straight angle? A straight angle is equal to 180 degrees. So that is going to be this one right there. So it also, even though it's forming a straight line, there is a initial arm, which is starting at that point right there and moving to the right, and the terminal arm is starting there and moving to the left. And the arc that's formed right here is 180 degrees. Now, all of the angles that we're making, they're usually measured from the initial arm to the terminal arm in the counterclockwise direction, so like that. Okay, the fourth one is called a reflex angle, and that's basically, the one we see right here that looks like it's on the inside, it's an acute angle, but instead of measuring the angle on the inside, we're measuring it on the outside right there. So that is a reflex angle. And a revolution angle, well, it's the last one right here. And basically that one is equal to 360 degrees. So it's important that you include that degree symbol, because otherwise the number 360 doesn't really mean anything. Okay, we're going to move on to another way of classifying angles, and this one's a little bit more complex, not as easy to understand. But we're going to go through it right now, and we'll definitely hit these concepts later in another unit. The first one are vertically opposite angles. This is when we have two lines that are crossing. And if we look opposite to each other, that would be this one right here and the other one on the other side. and we could call those A, and in this case we would say that A equals, equals A. So the angle at A equals the angle at A, and over here if I had an angle there, and we labeled those as B, I would have to label them both as B because those would have the same angles, stating that B equals B. Okay, now to create corresponding angles, the first thing that we're going to need are two lines that are parallel to each other, and then another line that crosses through, and we call this the transversing line. Okay, now basically you can see that this angle right here that's formed is the same as this one right here. So in this case, I would be able to state that this could be A, which means that would be A, and A equals A. And I can choose another one on the other side right here. I'll call this one B, and this would be the corresponding angle right down here that we will call B. In this case, B is also equal to B. Okay, now we're going to look at supplementary angles, and to make a supplementary angle we need a straight line, which is essentially 180 degrees. Off of that I need another line forming two angles. I have an acute angle on this side that we'll label as A, and I have an obtuse angle on the other side that we'll label as B. So in this case we say that these two angles are supplementary, which means that A plus B is going to equal 180 degrees. Okay, the fourth angle on our list is a co-interior angle, and to demonstrate this concept we again need two parallel lines and a transverse line. And the word interior means inside, so we look inside these two interior lines, and we've got these two angles right here. Okay, let's zoom in a little bit so I can make that angle right there. So we've got this one here that's A, and this one that's B, and we have the same thing happening as we do with the supplementary angle, in that A plus B is going to equal 180 degrees. All right, our second to last angle is called a complementary angle, and it's very similar to a supplementary angle. Just notice that the sum of the two angles in a supplementary angle equal 180 degrees, and the two angles that form a complementary angle in this case are going to equal 90 degrees. So this is a 90-degree corner down here, and when we look at this one right here that we'll call A, and the other one up here that we'll call B, we notice that A plus B is going to equal 90 degrees. And finally, the last one, the alternate angle. Again, we need two parallel lines, a transverse line, and we're going to be looking at this angle right here that we'll label as A. Let me do that again. Good. And basically, if you think alternate, it's on the other side, the other one. That is what alternate means, the other one. So we're looking at the other side for an angle that is the same. And it's not like this one that is opposite, it is this one right here, the alternate one. So this would also be labeled as A, and we know that A equals A. Okay, now we're moving away from just specific angle theory and moving into some shapes, and we're going to be looking at what are polygons. So polygons are geometric shapes that have at least three sides, and they're all made up of straight lines. So there's no curved lines in a polygon. We have two types. One is called a regular polygon, and the other one is called an irregular polygon. So with the regular polygon, we've got sort of our sides and our angles. And what do we know about the sides and angles in this case? Well, with a regular polygon, they are all equal. And with an irregular polygon, they do not have to be equal. So we look at the two shapes that are down below this. I've got a rectangle on the left and another four-sided polygon on the right. They are both called quadrilaterals as they're made up with four straight lines. So are these regular polygons or irregular polygons? The mistake that some students make is the one on the left they call a regular polygon because they say, hey, I have four angles that are all forming 90 degrees. So all these angles are the same. But remember that all the sides need to be the same. So in this case, I've got these long sides that are the same and the short sides that are the same, but not all four sides are the same. And the one to the right, you can see that we've got 1, 2, 3, and 4 angles that are all different. And I've got 1, 2, 3, 4 sides that are all different as well. So this would definitely be an irregular polygon. So what does a regular polygon look like that has four sides? Well, that would be our square. So we would draw that with 3 by 3 by 3 by 3. So I have a shape that has all sides the same and all angles that are the same. Okay, let's look at some different polygons and how they're classified. So how are they classified? Well, usually by the number of sides. So you can see up on the top left, we've got 3 sides, which is called a triangle. And on the right of that, we've got 4 sides, that's square, which is called a quadrilateral. To the next one on the left, below the triangle, that's a 5-sided polygon, which is called a pentagon, followed by a hexagon, heptagon, octagon, nonagon, and decagon. So these are all these shapes that we're looking at, these are regular polygons. They all have sides that are the same and angles that are the same. Now, you can see there's some information in there. If we look at the triangle, it says there are no diagonals. So what that basically means is that when I start in a corner, I can't, let me do that again. When I start from a corner, I can't get to another corner without following one of the edges. Okay, so we say it has no diagonals. Okay, and it has a sum of its interior angles is 180 degrees. So that means that, this angle, and this angle are all the same. And basically, I know there are 3 angles. The sum is 180 degrees. So that's going to be 60 plus 60 plus 60. So the sum of the interior angles is 180 degrees, but each angle in a triangle is 60 degrees. Okay, now what about a quadrilateral to the right? Well, it's got 4 sides and it has 2 diagonals. So where are these 2 diagonals? Well, again, I start to draw a line. I can't go there, I can't go there, but I can go to there. And if I draw a line off of this corner, I can go over to there. So these are the 2 diagonals. And it states right here that it's got a interior angle when added up, if we add up all 4 angles, it's going to be 360 degrees. So that means if I was to take 360 and divide it by the 4 angles, each angle would be 90 degrees. Okay, and you just need to take the same theory and move that down to all these other polygons. And I'll just do one more for you. We'll look at the pentagon. So it says it has 5 diagonals. So where are those? Well, I come off of here and I'm going to go over to that one. I can come off of here and I can go down to that one. I can come off of this one again and go up to here. That's 3. I can come off of this one and go to that one. And where's the last one? It's coming off this bottom one right here and moving up to there. So in this case, there are 5 diagonals, and it says that the sum of the interior angles is 540 degrees. So what I want to do is I just want to take 540 and divide that by 5, and we're going to get 108 degrees. Okay, so we've learned a little bit about different geometric shapes, and we've learned a little bit about angles, and now let's put it all together and take a look at these triangles and quadrilaterals and try to figure out the different angles that are presented to us. So the first triangle that we have on the top left is called a right triangle, and you'll need to become familiar with these terms as we move through this course. And how do I know it's a right triangle? Well, I can see that it's got a square in that corner telling me that that has an angle of 90 degrees. Now, to determine the other 2 angles, I would at least need to know what one of the other angles is. So in this case, if I look at this angle that's up top here, it's definitely less than 90, so it's an acute angle, close to 45 degrees. I'll call it 40 degrees. And now to determine this angle right here, I basically need to understand that the sum of all 3 angles is 180 degrees. So I just need to say 180 degrees minus 90 degrees minus 40 degrees equals 50 degrees, and now I know that last remaining angle is 50 degrees. Over to the right, we have a recognizable shape called a rectangle. And what do I know about rectangles? Well, rectangles have 4 equal angles, and that happens to be 90 degrees in each one of these angles. So as soon as somebody states that it's a rectangle, that means that each one of these angles is 90 degrees, and the sum of all 4 angles will be 360 degrees. Now the same is going to go for the square. So we have a square right here. The only difference between a square and a rectangle is that a square has 4 sides that are all the same. It is a regular polygon, but it still has 4 angles at 90 degrees. So all they have to say is it's a square, which means 90 degrees is the only angle that can be at one of these corners. Okay, now what about the triangle to the left? Well, in this case, I'll tell you that this is called an equilateral triangle. So it's equilateral triangle. And what is an equilateral triangle? Well, it has 3 sides that are all the same and 3 angles that are all the same. So to figure out the angle of each one of those, I don't even need any information other than the fact that it is an equilateral triangle. I know the sum of all 3 angles is 180 degrees. So to figure out the angle of each one of those, I just divide 3 into 180, which is 60. So that tells me that all of the angles in an equilateral triangle are 60 degrees. And it doesn't really matter the length of each side, it will always be 60 degrees. Okay, now we're down to our last 2 geometric shapes here, and in this case they're not really recognizable or named shapes. I just have on the left a triangle with 3 different sides and 3 different angles, and the quadrilateral to the right actually has 4 different sides, which means it would have 4 different angles. Now, the triangle on the left actually has a name, and it's called a scalene triangle. So a scalene triangle has 3 sides that are all different and 3 angles that are all different. So in order for me to determine this missing side right here, I need to know these 2 right there. Okay, again, I know the sum is 180, so it's going to be 180 degrees minus sort of the sum of those other 2 angles. So if I look at the top angle there, it's definitely more than 90, somewhere around, say, 120 degrees. The other one on the bottom left, it's an acute angle and it's close to about 40 degrees, so I'll call it 50 degrees. So essentially what we're doing is adding those 2 up. It's another way to sort of do it, and then subtracting them. So I've got 170, and subtract that from 180, and we're going to be down to 10 degrees. Now, this right here does not look like 10 degrees. It's definitely more than that, which means that I didn't really give this and this a value that matches the way it looks. Okay, but don't worry about the way it looks on questions. You want to go by the numbers that are provided to you. And these numbers add up to what we get right there. So 180 minus 120 is 60, minus 50 is 10 degrees. And the same thing would go with the quadrilateral to the right. So in order to solve this angle down here, which is unknown, we'll say, I would need to know the other 3. And I would also have to know that the sum of all the angles is 360 degrees. So let's see if we can get this one a little bit closer to what it actually looks like. Let's go with the top angle. It's definitely more than 90, so we'll go with, say, 120 degrees. The one to the far right is probably somewhere around 40 degrees, and the one that's on the far left would be somewhere around closer to like 100 degrees. So all I have to do now is take 360 minus 120 degrees minus 100 degrees minus 40 degrees, and I get 360 minus 120 is going to be 240 degrees, minus the 100 degrees is going to be 140 degrees, and then minus the last 40 degrees is going to give me 100 degrees. So in this case, the unknown angle would be 100 degrees.